I found out is that the sign on my Y-intercept was incorrect, which is why this was not working out in my life. So go back here. This should be a positive 324. Okay, and I figured that out because I wasn't crossing at the right spot. Okay, so we start positive. B means bounce. Let's swoop through my Y-intercept. Then I'm going to cross at 1. And then I'm going to bounce at 3. There you go. These aren't super beautiful. I don't know how high this goes. That's not what is important. What is important? Bouncing, crossing, bouncing, that my end behavior is doing what it needs to do, and that I have the correct Y-intercept. That is what matters in my life. Okay, last one that we're sketching. So Y-intercept, oh, this one's nice. I have this x squared out here, so that means my Y-intercept is going to be 0, 0. If you don't believe me, go ahead and plug that in. All right, so I have squared for my degree, then I have 1, 1, 1, 1. So 2 plus 1 plus 1 plus 1 plus 1. That is going to give me 6, which is even. It is a negative 4 for my leading coefficient. Most important thing is that it's negative for us right now. So even means they do the same thing. Negative means they're both going down. So as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to negative infinity. So my zeros, let's start with the first one, is 0 with a multiplicity of 2. So we don't want to forget this first one. Everyone likes to forget that one. 0, and then that has a multiplicity of 2. Then I have 3 with multiplicity of 1, 5 with multiplicity of 1, negative 2, multiplicity of 1, and negative 6, multiplicity of 1. So my sign chart, put these in least to greatest. So negative 6, negative 2, 0, 3, 5. All of those are crosses except for 0, which is a bounce. All right, so starts negative, cross, positive, cross, negative, bounce, negative, cross, positive, cross, negative. Good, that's where I should end up, right? Begin and end negative with this. Okay, so my Y-intercept we said is 0. So that makes this one a little bit nicer for that. Attempt to make a nice little scale, unlike me. So I'm going to plot my X-intercepts. So I have negative 6, negative 2, 0, 3, and 5. So I start negative and I'm going to cross. I'm going to cross again at negative 2. I'm going to bounce at 0. And then cross at 3. Cross again at 5. And overall my behavior ends up right. Once again, don't know what's going on with these mins, with this max. That's okay. We just don't want to end up with something like super jagged or anything. We want to avoid that. But any sort of smooth curve. All right, so let's go backwards, which involves writing an equation from the graph. So I want to identify my zeros first of all. So on this one I have negative 3. It's just passing straight through, so I'm going to say that's a multiplicity of 1. I get that from I look right at the x-axis. At negative 1, I'm going to say that's a multiplicity of 2 because it looks like a little parabola. Then I cross again at positive 1, multiplicity of 1, and positive 2, multiplicity of 1. So my degree, looking at this, the ends are doing opposite things, so I need that my final degree is odd. My overall graph is odd negative, so my leading coefficient I need to make sure is negative. My Y-intercept of this graph is 0, negative 6, and I'm going to use that to help me out in the next step. So I'm going to start with the information I have. So f of x equals x. Now I'm going to go to these zeros back up here and change them to factors. So instead of -3, I'm going to put x plus 3 to the first power times x plus 1 to the second power times x minus 1 to the first power times x minus 2 to the first power. But really, I have some sort of coefficient out here, and that's what I'm going to use my y-intercept to find. So I'm going to substitute in 0 for x and -6 for y. This should seem really similar to what we did with parabolas. It's like this class builds on itself or something. Crazy, I know. All right, you may have been noticing I don't actually need these zeros. I'm really just looking at these constants, but we'll just keep going. So I have 3, 1, -1, -2. So -6 equals 3 times 1 is 3, times -1 is -3, times -2 is +6, divided by 6. So my A equals -1. So my possible equation is f of x equals -1 times, go back to this line and copy it down, except for now you have an A of -1. Could I just put a negative? Yes. Do I have to put to the first power? No. I'm just trying to show where all of the steps are coming from at this point. All right. So let's look at this one. All right, zeros, I only have 2. Remember, we're only looking at where it crosses the x-axis. -5, and I'm going to say it's a multiplicity of 2, and +4, multiplicity also of 2. So my degree, these arrows are doing the same thing, so that means it's even, and they're both going down, which means my leading coefficient is going to be negative. My y-intercept on this puppy is 0, -400. Okay, so let's write my initial function. F of x equals, we're going to solve for a. Go back to your zeros. X plus 5, multiplicity 2, times x minus 4 squared. And let's solve for a. So -400 equals a times 0 plus 5 squared times, 0 minus 4 squared. So -400 equals a times 25 times 16. I'm going to show you something. Did you know you could use the box to multiply stuff like this? Should I just have a calculator handy right now? Yes. However, live and learn. All right. So that would be 320 plus 80, which is going to give me 400. So this is a really fun problem just to solve to find out that a equals -1. Is a always -1? No, Miss Vance just chooses the most awesome questions ever. So f of x equals -1 times x plus 5 squared x minus 4 squared. All right, we'll do this last one in class together. And if you flip back, to the second to last graph that we did right here, that I erased part of because, once again, it's a great day. All right, when we crossed here, I'm going to emphasize in class, let's make this, I forgot to emphasize the flat part, and we'll do some more to do that tomorrow, but we'll get really flat. It'll look kind of like a little baby cubic right next to the x-axis.